One of the questions that would come to mind as you think about digital systems and think about the two different representations that we looked at for the digital system, the truth table representation and the Boolean expression representation, is when is the truth table used and when is the Boolean expression used? Are there some ways to know, or are there some places where the truth table is more useful than the Boolean expression and vice versa? Okay, so let's think about that in this video. Now, let's say you want to design a system for an alarm in a particular lab. Okay, so let's say this lab is a clean room lab. Okay, so let me just draw a simple schematic here. Okay, and there is a kind of a entry way into the lab. Okay, and to enter into the lab you have to pass a double door system. So because you want to maintain the lab very clean, what you want is a person would, this door, let's call it door 1. So the door 1 opens and the person goes in here, and then the door 2 closes, and then door 2 opens and the person can go inside. That's just to prevent the infection or the things that are outside to infect things that are inside. Yeah? You might have seen or heard of systems like that. Now let's say what we want to do is we want to make a system that gives an alarm if door 1 and door 2 are open at the same time. Okay, so let's further assume that in the doors there is a sensor to detect whether the door is open or closed. And if the door is open, uh, the sensor gives you a value of, let's say, 1. And if the door is closed, it gives you a value of 0. Okay. Now I say, give me some, tell me how you're going to make this kind of a system. Now, it's not very straightforward, is it? To make a digital circuit that does this operation, but it's not very difficult to draw the truth table for this particular system. Now, let's think through how we can do that. So let's say you have two inputs, right? From the sensor at D1 and the sensor at D2, or you can say door 1 is open or closed and D2 door 2 is open or closed, and the output is your alarm. So let's say A. So what are the possible combinations that you can have? You can have the fact that both the doors are open, only door 2 is open, only door 1 is open, or both the doors are open. So I have these four different combinations. And for in all these cases, what I want is I want the alarm to be alarm to be off, right, in all these cases, except in this case where both the doors are open. Okay, well, I seem to have inverted my values, right? So this should be 0, and I should make this one because the open is 1. So when both D1 and door 1 is open and door 2 is open, I want the alarm to be high. I want the alarm to sound. Okay. Now, so this is the truth table of my operation. And as soon as I draw the truth table, you can see, well, that looks like an AND function. So what I want is A equal to D1 and D2. And therefore, you can easily build a digital circuit for this particular application. Okay, so let me kind of help you see what we have done here. We started from an application and we wanted to figure out what kind of a circuit does this operation. And one of the easy ways of doing that is to write a truth table for the application that you want. Okay, so when you are looking at an application and trying to decide what kind of a digital circuit you want, the best way to do that is to draw a truth table for that particular application. And once you draw a truth table, you might be able to, or will learn techniques of going from the truth table to the Boolean expression. Now, why do you want the Boolean expression? Because once you have the Boolean expression, it's very, very easy to make a digital circuit that does your work. So for example, here, as soon as we wrote the Boolean expression, we know that this is an AND gate, and you just get an AND gate and use it.